And when we're done with P7, we will do 2 or 3 days of review, and then we'll take a test over all of chapter P. All right, so we got a plan in mind. All right, here we go. We have, if I kept track of this, on page 6, we have these 2 problems to do, and they're kind of review problems, because we did one of these yesterday, and we did one of these yesterday. So, who remembers, this is 4A on page 6, who remembers how we do this? FOIL. We're gonna FOIL. This is not combined like terms. If there were a plus sign in between, then we would combine like terms. But there's no sign in between, so that is gonna be a multiply. This is gonna be a FOIL. Does everybody see that?
Yes.
Okay, so here we go. First, outside, inside, last. And remember, when you multiply 2i times negative 7i, you get negative 14i squared. All right, so now we cleaned it up. These 2 obviously add, they are like terms, so that will be negative 13i. And then what about this guy right here?
Goes to a negative.
He becomes a plus 14, which can add to the 12 and make 26. And that's it, that's the answer. Okay, not bad. All right, what about this guy? What do we do here? Multiply by the conjugate of the denominator. And the conjugate of the denominator would be what? 3 plus 2i. Remember, you just change that sign. And you do it for the denominator. Okay. So here we go. FOIL on the top. And FOIL on the bottom. What happens on the top when we clean that up? Looks like I'm gonna have a 31i. What's this? Negative 14, so 15, that's just 1. Plus 31i. And then what happens on the bottom? This will always happen. These are gonna cancel. That's gonna become a plus 4. So the whole shebang's over 13? We okay with that? Pretty easy. Pretty easy. Okay. All right, we have one more section to do. And P7 is all about inequalities. So we're gonna learn how to solve various kinds of inequalities. Now, this is called an absolute value inequality, and it can be solved, and in fact it was solved last year by breaking it apart into 2 different pieces and solving the individual equations. I want you to think about a different way of solving this. A very simple way to solve this is to draw a number. And right in the middle of that number line, put the opposite of that number. So put 2. okay? Now, count forward this far. So count forward 3. Where would you be if you started at 2 and counted forward 3? 5. Put a dot there. Now, count backward 3. Where would you be if we went backward 3? -1. That okay with everybody? Now, this says, now I actually counted exactly 3. This says I should have really counted more than 3. So where would I be? If this is exactly 3, more than 3 would be out there. And more than 3 this way would be back here. So my answer is this part of the number line and this part of the number line, because I have to be more than 3 away. So my answer is everything from -infinity to -1. This is -infinity, remember? Or, whenever you have 2 pieces, you're going to have a union, an or, 5 to infinity. So if I do the problems this way, this is actually the calculus way of doing these problems. I really don't have much figuring to do, like in terms of solving equations. I just do it totally on a number line. This says the distance between my answer and 2 is more than 3. So here's 2, count 3 this way, 3 this way, and then more than. That's all there is to it.
Will the like smaller number always be like?
No.
So
No, doesn't have to be.
okay.
Doesn't have to be. All right, so let's look at the next one. It's exactly the same thing. Here's my number line. Start by putting what right here in the center of the number line? What goes there? -5. Because in the center of the number line, that's like your beginning point where you start counting. In the center of the number line is the opposite of this. Okay? Now, I'm going to count out here and put a dot, and I'm going to count back here and put a dot. And how many am I going to be counting? 6. So if I start at -5 and count 6, I'll be at 1. And if I go back 6 this way, I will be at -11. Now, this time the dots are closed in. Would you agree with that? Which means when I do my intervals, there'll be brackets. And this time, remember we counted exactly 6. I really was supposed to count less than 6. So where am I shaded this time? If I'm less than 6, I'm going to be shaded in between. In between the 2 numbers. You counted forward 6. You were supposed to count less than 6. So like count only 5 or 4 or 3. So you're in here. Greater than is going to be out. Less than is going to be in. So my answer is just everything from -11 to 1. That's all there is to it. All right, so let's look at the next one now. It's a little different. Does anybody notice anything different about this? There's a 2 right here. Just like with completing the square, no, can't be. Divide it out. Can't have a 2 there. So we're going to have x minus 4, greater than or equal to 7/2. You can do 3.5 if you want, 3.5, whatever works for you. Now I'm ready to go. So what goes in the middle? Where am I starting from? 4, +4, always the opposite. +4. Gonna have a dot out here and a dot out here? How far am I going to count? 3.5 or 7 halves if you're using fractions. If you count 3.5 this way, we'll be at 7.5. What if we count 3.5 this way? 0.5? Is everybody with me to here? Okay, so now we gotta figure out where we're shading. First of all, the dots should be colored in, right? And then it's a greater than problem. So where do I shade when it's a greater than problem? Out. So my answer is negative infinity, comma, 0.5. Remember always the infinities are parentheses. Or 7.5 positive infinity. Kendall, you with me here? Okay. Oh my, look at D. What is wrong with D? Does it look backwards to you? Okay, so I'm going to show you something. I think you already know this, but we have to be careful with it. If I am taking absolute value, are these two things the same? If I'm taking absolute value. So what's 4 minus 3? 1, and the absolute value of 1 is 1. What's 3 minus 4? Negative 1, but the absolute value of negative 1 is 1. So are these two the same? Yes. Only in absolute value you can turn your subtraction around. So if you don't like that order, I do not. I am allowed to turn it around. Nothing else changes. I just turn it around. Why am I allowed to do that? Because when you take the absolute value, subtraction order doesn't matter. It does in the real world, but not in absolute value. Okay? So now what? Divide everything by 4. Again, we can use fractions, or you can use decimals, whatever is easiest for you. Here's my number line. Where's my starting point? Positive, 3/4. Always the opposite. This number, by the way, is never your answer. Your answer is going to be these 2 points out here, right? And where are they? How are we going to get those? We're going to start at 3/4 and add 9/4. Wouldn't that give me 12/4 or 3? And then I'm going to back up 9/4. So 3/4 minus 9/4 is negative 6/4 or negative 3/2, negative 1.5. Yep, if you're using decimals, 1.5. Those dots are open in this problem. And where are they shaded? In between. So the answer to the problem is negative 3/2, comma, 3. Those are absolute value inequalities. We're switching to a new kind now. So let's try to remember that process. Okay? The process is x has to be by itself. So if it's not, divide. The opposite of this number goes in the middle, and then we count back and forth that much. If it's a greater than, we shade out. If it's a less than, we shade in. Good? Alright, number 2, totally different problem now, because number 2 does not have absolute value. This is what we call a polynomial inequality. This one happens to be quadratic and squared, but if you look down, we got some cubed ones down there. X squared minus 4x minus 5 is greater than 0. Okay. Anybody have a guess what we might do to start? Factor? Yeah, that's a great strategy. So who can tell me how this thing factors? This is what we mean by factoring. We're gonna set up a couple parentheses. Who can tell me what that is? Yep.
X minus 5, X plus 1.
Plus 1? Yeah, perfect. Now, we're gonna be factoring, actually, all these problems. I don't know where you are in your factoring, but remember, if you're at all unsure, you can always FOIL it back. And what should happen when you do your FOIL on your factors here, it should bring you back to your original problem, right? If it doesn't, then you factored wrong. And if you factor wrong, your answers are gonna be wrong. Okay, so you double check your factoring to make sure you got it.
Is that supposed to be 4?
Is what's supposed to be good.
The 5?
Negative.
Doesn't it have to multiply to 4 though?
Oh.
And then add to 5?
No.
No, the outside
Look, when
one.
you FOIL, this times this gives you this
Yeah,
number.
I gotta.
I'm so confused.
I
Right?
thought it multiplied to 4, added to 5 at the original.
No, it's the,
No, that's wrong. Whatever you thought there, that's wrong. It multiplies to this number and adds to this one as long as there's no coefficient out in front. So, if you, Leilani, what was your guess?
I thought it was gonna be like
Yes.
negative 4 plus 1.
Minus 4 plus 1?
Yeah. 'Cause
Okay, now just stop. No need to be confused here. All you have to do is check it. Check it.
Oh, no.
When you FOIL this, look girls, what happens when I FOIL this? What do I get on the end? When I do last times last, what do I get? I get a negative 4. And what am I supposed to be getting? A negative 5. So whatever you put here and here has to give you that number. It can't be 4. Now, these two will add up to the negative 4 that you wanted. So this is, he's right, that's the correct factoring. Okay? Now here's the thing that gets so frustrating when you're a teacher. You guys have control of this. Factor the way you think it should be factored, and then check. If it doesn't work, then you gotta try something else, okay? Don't just slap something down and move on. Check it, make sure it's right. All right, so we are factored. Here we go, we're factored. Now draw your number line. Remember how in the last problems there were 2 dots on the number line? There are 2 dots on this one too. Any guesses where those 2 dots might be in this particular problem?
5,
Watch it. Positive 5 and negative 1. So just like before, we take the opposite. They're going to be open dots. Right? There's my 2 dots. They're open dots. And it's a greater than, guys. Where do I shade greater thans? Greater thans are always shaded out. Now I gotta qualify that. They're always shaded out when there's only 2 dots, okay? That's a 2 dot rule. If we have more than 2 dots, then we have to use another strategy. But if there's only 2 dots, less than's gonna be inside, and greater than's gonna be outside. So what's my answer? This is not the answer.
Negative
Negative infinity to negative 1
union
in union with 5
5.
to infinity. So I'm really using the number line to solve the problem, but I have to write my intervals in the answer blank. All right. How about the next one? Looks very, very similar. So what do we do first? Factor, all right. Girls, you wanna take a stab at this factoring?
X minus 1 and X plus 10.
-1 plus 10, she says. I think she's right, but I'm gonna double check it. X squared plus 10x minus x minus 10. Do these add up to plus 9? Yep, minus 10 on the end. She's exactly right. That's my check. She's got it. So then I'm gonna draw a number line, put 2 dots on the number line. Where will they be? Daniel, where will my dots be?
-1.
Be careful. Actually, it's the opposite. So it's going to be -10 and +1.
Okay.
Always the opposite. Look here, Daniel. We did +5 and -1. See that? And one thing I didn't mention is, that is a number line. So when you put your -10 and your 1 on the number line, they gotta be in that order. And they gotta be where they are on the number line. They be closed in dots this time. And where will they be shaded? In between. So my answer is -10 to 1 in the brackets. That's exactly right. Isn't this easy? I mean, there's some things you have to remember, but it's pretty easy. All right, would you try C? And maybe try it and then compare your answer with your partner there. See what you come up with for C. Okay, have we factored? We should all have, at least have it factored. What did we come up with as the factors?
X minus 5, X plus 2y.
Plus 2 and minus 5, I heard, is that right? Those look okay to everybody? No question about that. If you miss that, you miss the problem, so you gotta get that part right. Good? Number line, where do the dots go on the number line?
-2.
-2 and +5?
Yes.
We're gonna leave them open, the open dots. Eli, what are you doing? Your mom is texting you. Okay, I love mothers, I am a mother, but not during that class. Put your feet on the floor. No. You heard me screaming at football about that the other day. All right, so we've got our open dots, now we got a shade. Where do we shade? In between. So the answer to the problem should be just this. That's it. All right, how many of you got that on your own? Okay, if you didn't get it, Seth, you paying attention?
Yes.
Actually, you're not. If you didn't get it, do you have a question about that? Okay. One more. Let's go ahead and do that last. Well, I mean, D is the last one like this. Now we gotta shift things a little bit. Be careful on this factoring. This is when we sometimes get mixed up. How's that factor? Luke, you got a thought on that? How that we factor?
X plus 5. X plus 1.
Okay? I'm glad Luke said that because this mistake is made hundreds of times. I want you to look carefully and foil this. Luke, what happens when I foil this? Do I get what I wanted up there? No. So our next try is x plus 6, x minus 1. Is that right? All right.
Minus 6.
Minus 6.
Right. Kaya just might have.
Okay, now Luke, look. X squared minus x minus 6x plus 6. Now I got the plus 6 this time, that's good. But what about that? It's not the right answer. This is okay. This is what happens in the world of factoring. You mess with it till you get it right. All right, so what do you think, Milani?
X plus 3, x plus 2.
She's trying x plus 3, x plus 2. All right, let's check that one. I think she's got it, right?
Yep.
Factoring is easier for me because I didn't grow up in the Google world. Now you guys want to press a button and have the answer, and factoring doesn't work that way. You gotta plow away at it until you finally get it. So that's perfect. So here's my number line. Where are my dots? All right, and be careful when you put these on here. This is the order they go, right? Because they're negative. Those dots should be solid. And where am I shaded? Out. So negative infinity, negative 3. Union with negative 2 infinity. Quadratic inequalities, we're good. All right, E is different because what? What is different about E? It's x to the third. It's x to the third. And when you have an x to the third, you are going to have 3 dots on your number line. Okay? So now we don't have the outside inside stuff anymore. We only have that when we have 2 dots. 2 dots greater than out. But with 3 dots it changes. First we have to figure out where the dots are. We have to factor that. Anybody have a thought on how we might factor this here?
X.
Take out an x.
And then parentheses.
So first things first, GCF. GCF. So x squared minus 2x minus 8.
Yes.
Does that look like the ones we just did? So now we got our x, it has to stay there. And now we'll just factor the part that's left. So how will that factor? X
Minus 4.
minus 4
Plus 2.
plus 2, he says. You with that? Everybody okay? So here's my number line. Here's my 3 dots. Every X gets a dot. So 3 X's, 3 dots. Where will the dots be? Well, this one's easy. 4, -2. What do I do with that? 0, 0. A plain X is a 0. Some of you said make it a 1. No, I would make it a 1 if I had that factor, right? 0. So I've got a dot at 0, at -2, and at 4. And you gotta make sure, this is so important, so obvious but important, get them in the right order on the number line. Okay, so am I good? Okay. Now, if this only had 2, alright, this is gonna be too confusing. So here's what we do, here's what we're gonna do. This number line has been split up into 4 pieces. Would you agree with that? 4 separate chunks? I need you to pick a number, one number, in any of those chunks. Now, you can't pick these. It has to be a number that's inside a chunk. So pick a number. What? +2. +2 would be right here. Would everybody agree with that?
Yep.
I want you to go back to your problem, and I want you to put a +2 in for all the x's. So she said we're gonna let x be 2. Okay, we can do that. So if x is 2, I have 2 times -2 times 4. What's 2 times -2 times 4? What is that times all together to make? -16. Is -16 bigger than 0? -16 bigger than 0? No. That means that the chunk of the number line where we picked our number, we don't shade that chunk. Because that number didn't work. It gave us -16, and -16 is not bigger than 0. So if it doesn't work, you don't shade it. Here's the good news. If that chunk doesn't get shaded, this one will, this one will, and this one won't. In other words, we have a every other one shaded. So you tried one section, you only need to try one. We happened to pick this one. It didn't work. So that means the ones on either side of it will work, and that one won't. They go every other one. Now, if hers would have worked, let's say we did this and got +16. +16 is greater than 0. So we would shade that one. Where else would I shade? I would shade that one. And this one. Okay. So what's my answer? Should these be colored in? No. So my answer is -2 to 0. And then 4 to infinity. Is that okay? All right, let's do one more. Now, it's a cube, which means ultimately I'm gonna have 3 dots on my number line, 3 X's. I gotta get this thing factored. We will learn, I think it's chapter 2, we'll learn how to factor harder problems than this. But right now, I see a GCF, do you? So whenever I see a GCF, I take it out. So what am I taking out? X. What am I gonna have left? X squared minus 1. Now wait a second. What about x squared minus 1? Who remembers that? That's special. Someone?
Is it both plus 1 and minus 1?
Yeah, it's called the difference of squares. So x plus 1, x minus 1. Remember that? If you have x squared minus 9, that will be x plus 3, x minus 3. Remember that difference of squares? So if you had x squared minus 25, x plus 5, x minus 5. So here's my number line. Where do my dots go? There's 3 of them. 3 x's, 3 dots. -1, 0, and 1, Cam says, in that order. I don't care what order the factors are in. On the number line, you gotta have your numbers in the right order. And those would all be solid dots this time. And we gotta figure out where to shade. Okay? I know my shading is either gonna be these 2 sections or these 2 sections. I'm just not sure which it is. So I'll pick a number. And I heard somebody say 2. What a great choice. Because if you tried to pick a number in here or in here, wouldn't it be a fraction? Yucky. You have a choice. 2 is a great number. It's out here. So I'm gonna plug 2 in. For all the x's, I'm putting in 2. So 2, this would be 3, and this would be 1. What's 2 times 3 times 1? 6. Is 6 less than 0? No. Which means again, we picked a loser, right? It didn't work. So if we're not going to shade this section, then we are going to shade this one. No. Yes. So the answer to the question, negative infinity, -1. Remember, this is negative infinity out here. Or union 0 to 1. All right, we don't have time to get started on a projectile motion problem, but we will do that. I guess not till Friday, huh? You guys have to wait till Friday to do your projectile motion, sorry. What? You all right? That's all right.